This is monomial division. Monomial meaning, remember, say monomial. It's going to actually be a polynomial by a monomial. But you reduce it down to a monomial divided by a monomial. Long division, for those of you who are used to doing some of this stuff, long division. Long division does not work well for this type of division unless you really know what you're doing. And you really have to know what you're doing. Otherwise, you'll end up with a completely different answer. And then it gets messy, and then you get confused. What essentially this is, if I have a single term, meaning a monomial, what you do is you will divide that denominator into each piece. So this would turn into take the 10x to the 8th divided by the 5x cubed plus, and there's that plus that's in the middle right here, a 15x to the 6th divided by 5x cubed. So you take it from one big clump into two individual pieces. Now you divide these two pieces. Now what your book does and this example does, and you can do it more than one way, is it uses the property of exponents. The property of exponents it's using is this one that says if you have a to the m divided by a to the n, if the bases are the same, then you subtract the exponents. For some of us, we're just used to canceling. So if I had x to the 3 divided by x to the 2, you'd say, oh, I've got 3 x's on top, I have 2 x's on the bottom, and if we reduce down like we did in the previous section, those 2 x's form a 1, those 2 x's form a 1, and what you're left with is a single x by itself, namely an x to the 1. That's the same as saying x to the 3 minus 2 is x to the 1. You end up in the same place. And it depends upon how comfortable you are as to which you would use. I tend to cancel myself. This would take 5 divided by 10, which turns into a 2. And if I have an x to the 8 divided by x to the 6th, it's x to the 3. It's going to be x to the 8 minus 3, which is going to give you an x to the 5th. 15 divided by 5 is a 3. And an x to the 6 divided by an x to the 3 is x to the 6 minus 3, which is going to be x cubed. And then you'd come up with your final answer. So if I were going to do this problem, the first thing that I would do is I would break it into its individual pieces. I don't try long division on this. This is 49, x to the 7th divided by 7, x to the 3 minus, and that's this minus sign right here, 28, x to the 5 divided by 7, x to the 3, and then plus, that's this plus sign, 14, x to the 3 divided by 7, x to the 3. Now you could use the property of exponents on it, which says 7 minus 3 is going to be 4. You're going to have 4 left. Or you can be like me and say I've got 3 in the denominator, I've got 7 in the numerator. If I take 3 from the 7, I end up with a 4. So 7 divides 49 7 times, x to the 4th. So 7 divides 7 once, divides 49 7 times. Minus 7 divides 7 once, divides 28 4 times. And I have 3 in the denominator, I have 5 in the numerator. If I take 3 from that 5, that's going to give me a 2. So it's going to be 4x squared plus. And here, this is 3 in the denominator, 3 in the numerator. So essentially, this forms a 1, so it's gone. 7 divides 7 once, divides 14 twice. You're just left with a 2. I don't care what way you do it, whether you cancel, reduce out that way, or whether you use the properties of exponents. Does not matter to me. Yes?
What if we can do all that work in our head, like just leave the answer?
That's fine.
You can just be the right or
Now
wrong.
here's, yeah, and then it makes it right or wrong.
Yeah.
So if you make one little misstep,
Oh, no, I
or one little error on a test, then you don't get partial credit, yeah.
Sweet.
And that's the problem, because there's nothing to back up what you did. And besides, on an exam, you could be here, but your mind might have actually decided it's going to Hawaii without you. And for some odd reason, you're here, but your mind is not. And I've had that happen. I didn't even know it was gone, and it was gone when I took the test. I knew it was gone when I got the test back. That's when I knew it was gone. So that's why, with a test situation, it's always good to put in that extra step, because that kind of saves you from making errors that you wouldn't have made otherwise. On homework, doesn't matter. But on a test, I'd always put in the extra work, because it saves you. It also gives you extra points, because it's partial credit. It also saves you from making some of those, well, you will say, stupid errors that could be avoided. Now, on this one, this is the same thing as saying it's this whole thing divided by minus 2x to the 4th. So I'm going to take 2x to the 4th, and I'm going to divide him individually into each one of these pieces. So this becomes 18x to the 7th divided by negative 2x to the 4th minus 9x to the 6th divided by negative 2x to the 4th minus, or plus, 20x to the 5th divided by negative 2x to the 4th minus 10x to the 4th divided by negative 2x to the 4th. Now, negative 2 divides positive 18. That's going to be a negative 9. If I were using the property of exponents, I have x to the 7 and x to the 4th. This would be x to the 7 minus 4. Or you can cancel. A minus and a minus does what? Forms a plus. Unfortunately, the 9 and the 2 don't do anything, so I'm going to have a 9 halves and an x to the 6 minus 4. And now I have a plus and a minus, and a plus and a minus form a negative. 2 divides 20 10 times, so I'm going to have a 10 x to the 5 minus 4. Minus and a minus is a plus. 2 divides 10 5 times, so it's 5 x to the 4 minus 4. That's going to be x to the 0, but I know x to the 0 is 1. So this becomes negative 9 x to the 3 plus 9 halves x to the 2 minus 10 x to the 1 plus 5x to the 0, and x to the 0 is 1. And then that's your answer. Now that's that problem worked the other way. And you'd end up with the same answer regardless of what way you worked it. Yes?
Wouldn't you get rid of the 2?
Which 2? This one?
The 2 in the denominator? Yeah.
No, because 2 does not divide 9. The only way you could do this is turning this instead of into a 4.5.
No, well, like, or you can, like,
Multiply everything by 2.
to get the whole fraction.
can't multiply everything by 2 because it doesn't have an equal sign. Yeah.
What
Can I leave it as 4.5x squared?
Sure.
Okay.
And we don't need to factor this out, this is the final answer?
That's the final answer, yeah. See, the best I can do is I can change the 9/2 to a 4.5, or I realize that this is x squared over 1, and then you rewrite this as 9x squared divided by 2. That 2's there to stay. And it would be nice to be able to get rid of it, but because this is an expression, not an equation, there aren't two sides you can, with our equations back in 6A, you multiplied both sides to code a fraction. Unfortunately, I don't have two sides. Would be nice, but doesn't happen that way. That's one that's dangerous to do in your head. Now remember, this is all over 10x cubed y cubed. So this becomes 40x to the 4th y cubed over 10x cubed y cubed minus 20x cubed y squared over 10x cubed y cubed minus 50x squared y over 10x cubed y cubed. Now you reduce things down. 10 divides 10 once, 40 4 times. X cubed takes out an x to the 4th, giving me just an x by itself. Y cubes take each other out. So the first term is just 4x minus 10 divides 10 once, divides 20 twice. X cubes take each other out. Now this is where things get dangerous because I have two x's and then 2 y's in the numerator. I have 3 in the denominator. So 2 takes out 2 of those 3. That y is in the denominator. Minus 10 takes out the 50, giving me a 5. X squared takes out 2 of those 3, gives me a single x. Y to the 1 takes out 1 of those 3, leaving me with a y squared. So I'm left with 5 in the numerator and xy squared in the denominator.
You wouldn't combine the two y's? You would just leave it like that?
Mm-hmm.
Okay.
They're different.
Because they're different. This one's a y and that's an xy squared. So they're different. And that's when we say yippee, because they're fractions.
Right.